Hello everyone, welcome to this video number 4 on analytical simplification. This is unit 6 of computer methods in power system of BTech. Now in this video we shall learn how to analyze line to line ground fault using two component method. So already three component method we have learned and we have seen that the positive negative sequence they are connected in series and that is connected in parallel with zero sequence network through the fault impedance. Now we have to do it. We have to find out the interconnection of sequence networks with two component theory. So let us start. Consider a line to line ground fault as shown below. So here is shown a three phase transmission line. We have A phase, B phase, and C phase. And there is a double line to ground fault on B and C. So you can see here the B and C, they are shorted through the fault impedance ZF and they are connected to ground through the ground impedance ZG. So these are the respective currents. From phase B we get a current IB, phase C we get a current IC, and these two combine together to get current here as IB plus IC. In the from phase A, the current coming out from the phase A, IA is 0 because there is no current comes out of phase A, so IA is 0. And here it is shown the voltages of each of the phases VA, VB, and VC. Now from this fault we can write the boundary conditions as IA is 0, that is no current coming out phase A. VB is equal to ZF into IB plus ZG into IB plus IC. So obviously VB, this is the potential with respect to ground. So here, so it is equal to the voltage drop across IB plus ZF and then plus the voltage drop across the ground impedance ZG into IB plus IC. In the same way, we can write VC also, the voltage of this phase with respect to ground. So it is also equal to the voltage drop across the fault impedance and the ground impedance. So it is sum of the voltage drops. Now from these boundary conditions, we have to find out how the sequence network of two component theory they are connected. So as we know that we have three networks. One is positive sum network, then we have positive difference network, and the next one is zero sequence networks in two component theory. So we want to find out the interconnection. So using the two component model. So this is the two component model for the current. So here I0, I summation, I delta, these are the sequence currents, and here we have the fault currents. So IA, it is substituted here 0, IB as it is written, IC, and this is the transformation matrix we have. Here H can be taken as 1 as I told in earlier videos also. So by doing multiplying this matrix into this matrix we get here this. So this is I plus IC which is equal to IA naught, and I summation it is equal to minus IB plus IC, and I delta is equal to J root 3 IB minus IC. Now from this equation we can say that I0 or I naught is equal to minus I summation. You can see here these two are equal and they are with minus sign. So these knowledge about the sequence current gives you one hint that zero sequence network I0 it is related to zero sequence network, and I summation this is positive sum positive sum network. Now we can see these two networks, they are they should be connected in parallel because this equation says that they are equal and opposite. When we have opposite, so when I not flows this way and I summation flows this way, it means that the two networks they are connected in parallel. So this gives you this hint: zero and positive sum network they are connected in parallel. Next, from the second and uh, third boundary condition. So this is our second boundary condition and this is the third boundary condition. Now if you do VB minus VC, we will get ZF IB minus IC. So because this second term here and this second term will get cancelled, then we will have ZF IB minus IC. But what is IB minus IC? So this is IB minus IC. You can see it from this equation here. You see here IA delta it is equal to J root 3 IB minus IC and divided by 3 is there. So 1 by 3. So this IB minus IC term we can take it out. So it is equal to uh, this term. So J. So from this equation you see here, from this equation we can get for IB minus IC, and whatever we get you substitute here we'll get this equation. Okay, but now but this is the two component model of voltage two component model, and here also you can take H is equal to 1. Here you have the phase voltages VA, VB, VC, and here we have the sequence components, and from this equation you will get, if you do this VB minus VC, second row minus third row, if you do, then we will get this equation. Now you let this equation be A and this equation be B. Now from equation A and B, you can see here, we can write this quantity ZF I delta and VA delta, they are equal. So VA delta is equal to ZF I delta. So this is the equation of positive difference network. So this is the equation of positive sequence, positive difference network. Okay, so it means that there is a positive difference network is existing. One point, this is existing, and these they should be connected in parallel. That is what we have proved here. So this implies this connection. So this is already I told what this equation. So the above equation says this interconnection of sequence network. So we can see that this is positive difference network. So what is the equation? The equation of this network is here. So VA delta is equal to ZF into IA delta. Okay, and this network says that this is zero sequence network and this is positive sum network. They are connected in parallel. By analyzing these circuits, so if you find I summation or I naught, or if you find I delta, by analyzing these two circuits, we can find the sequence currents and then we can find the fault currents. And also we can find the fault, the fault voltages. So this is how we can analyze line to line ground fault using two component method. So here uh, here to be understood that positive sum and zero sequence network, they are connected in parallel, and positive difference is existing and it is separate. We have to analyze. So by analyzing these two circuit, we can do the line to line fault, line to line ground fault analysis. So in this video, up to this only. Thank you very much. So this is our last video, maybe for this semester in for your exams. So thank you very much.